right, all right. Hello, everybody. Hello out there. Hi. How's it going? I am Aaron from Solace, back with you for yet another Office Hours. This is the February 2023 edition, and I am coming live at you from Singapore, where it's actually March 1st. But that's because, we're doing a North American time zone here, so it's still February. Back in North America. I have a very exciting episode for all you people out there. Today is going to be all about partitioned queues, and to help me present, or to actually, to do all the presenting themselves, I'm going to bring in my special guest, Rob. I'm going to add you to the stream here. Hello.
Hey, Aaron. How's it going?
Pretty good. How are you, man?
Not too bad. Not too bad.
So it is still February where you are, right? So
it is still February for 12 more hours.
I'm in the future, and I'm in March already. So why don't you introduce yourself there?
Yeah, so I'm Rob Tomkins. I'm Principal Core Product Manager here at Solace, and that means I get to play around with some cool stuff like product managing, distributed tracing, Kafka bridging, and partition queues. So pretty exciting stuff coming down the pipe here.
That's right. I think 2023 is shaping up to be a big year in terms of cool features, broker features, lots of interest and stuff. So, yeah. So, good morning, good evening, good night, wherever you're watching this, or if you're watching the recording. Thank you for checking it out. For those that are live, I always like to kind of find out where people are joining us from. So, I'm as I said, I'm in Singapore. Rob, you're in Ottawa, correct?
I'm in Ottawa, yeah.
Ottawa, Canada. Okay. So say hello if you're out there. Always nice to see some people out there. Hey, Srinivas, how's it going? Hello, welcome to the stream. Thank you for being here. Okay, so Rob, partitioned queues. This is a feature that's been in the works, I think, for a little while. It's taken some time to kind of build. It's not like a little small thing. It's quite a big feature, right? So why are people wanting to have partition queues?
People are wanting to have partition queues because they want to have an ability with a queue to load balance and yet have context awareness, so that you can have the same consumer consume the same material having to do with the same order or the same employee or whatever the sort of context is.
Related data.
Yeah. And they want to be able to do it with auto scaling, so that they aren't tied to a fixed number of consumers, and have the whole system just figure out the best way to flow those events from one point to the next.
Yep. Cool. All right. So we're going to share some slides, I think, that you have to kind of give a little bit of overview. Got a few more people. It's from Charlotte, North Carolina. Excellent. Welcome. Jason from Utah. Hello. Thanks for joining us here. Janu Kumar. Hello. Welcome. And you're joining us from Bangalore. Excellent. So pretty late in the evening there. Not as late as Singapore, but hope
really?
Thanks for staying up for us. All right, cool. Rob, do you want to share? Yeah, I can see it. I'm going to add it to the stream here. Boom.
Excellent.
Let me get rid of this banner here. So yeah, give us a little pitch here. Let us know what's up.
All right, so let's go through an example of partition queues, and in a way, what partition queues really are kind of Solace's answer to partitioning that you see in Kafka. And if you think about a partition queue, it's sort of like a consumer group within Kafka, but with added benefits. So I'm going to take you through, a scenario here. You're a consumer or a customer. You're a retail vendor, let's say, right? So you're going to take in orders from online, and you want to build a service that takes, an order from your website and passes it through an exclusive queue, gets handled by a consumer, which is, a typical microservice. And you're starting out your retail service this way, brand new business. And so, that works, chugs along just fine, and you're getting all your events. It's an event-driven solution, and let's say you're really successful. This really working well, and that's going to put more and more pressure on top of your consumer.
The load goes up. Yeah,
Yeah.
it's a good problem to have, actually. So
It's
if
an
a
excellent
business,
problem to have,
yeah,
right? That's exactly what you want to see. Uh, but what do you do next? So, a lot of customers would move on and replicate that microservice. That's what a microservice is for, right? So if you create some replicas, and you can build out a non-exclusive queue with Solace, and non-exclusive queues do an excellent job of load balancing that event load to multiple different consumers. Where partition queues come in is, what if you actually want to be a bit more sophisticated in your consumer? Let's say, you're moving on, you're evolving. I want to be able to allow my customers to modify their orders, and modify them after it's gone through the initial web page, but later on they come back in, they make changes. I've got to feed that now through my event mesh and make changes to the consumer that handled that initial request. And that's a problem with non-exclusive queues. If you forward that second order, it would go to likely a different consumer. And unless you've got these consumers connected through cloud or database or something to share the context, a non-exclusive queue would work. Now,
yeah.
okay,
So like the
absolutely.
non-exclusive queue is just completely round robin, right? It's just and obviously the more consumers you have, the less likely a related message is going to go back to the same guy, because it's just round robining that entire list of consumers there.
That's
so
right.
You're saying, so they would have to have some shared state or in-memory data grid or some backing kind of store that if they could go look up. So here we see order 22 going to two different people, and that's kind of a problem. So they'd have to go and figure out how to do that. So
that's kind of a problem. Yeah.
Right. Okay. So round robin is not always going to work for us, right?
That's right. It's not always the right solution. So if you want the same consumer to always consume the events for a particular data set, what we've developed is partition queues. And partition queue comes in, it's got load balancing, and it's context aware. Well, how do you add context? Well, here we're doing it in a very similar way to what you see with Kafka. We add a key, right? And
who adds the key?
That's added actually at the publisher.
The publisher adds the key. All right.
So at the same time as partition queues comes out, we're changing all our APIs. So our APIs will allow you to add a key. And we actually are putting this into the JMSX group ID, which was actually developed a long time ago for exactly this purpose. And I think we're actually the first broker in the industry to actually use it in the proper way. Typically, it's just kind of passed along through the brokers to the consumers. But here, we're actually going to use it to hash into a partition. So that's the next step. Is you take a hash, and the hash will make a determination of what partition that message gets put to.
So you're showing here we have 10 different partitions.
Yeah.
And the numbers, I guess, are just kind of illustrative of kind of how the load would be spread around, right?
Yeah, that actually reminds me, I should kind of change this, because you got to look at the hash function as basically a random number generator that will always give you the same number if you give it the same key. Otherwise, you don't exactly know where it is. So it's not as
not a modulo like this slide
as modulus as this is showing. Yeah. Exactly.
Yeah. Okay.
Yeah. I just find it easier when I'm walking people through this to have something a bit more consistent, but in reality, it's going to be kind of all over the place, right? And then what happens with the partitions is we map every partition to one and only one consumer. So if you go into a partition, it always goes to the exact same consumer.
Right.
Like that, right?
Okay, so here we have 5 consumers, and they're each getting 2. Some 2. We don't know exactly which 2. Is it kind of random, or that like how's the mapping done?
So the way the mapping is typically done is the first one will connect. The first consumer to connect will be to the first partition, and that first one will actually get all 10, and then second one comes on and they'll do 5 and 5, and then the third one comes up.
Okay.
But over time it'll all kind of balance out, but this would not be an atypical early view of how this would work.
Okay. Cool. All right. Sorry to keep interrupting you with all these questions, Rob.
No.
People might
dialogue is good. I don't want to be a broadcaster here.
Hi to Mimi. Just saying a few highs on the chat here. People telling me from Vancouver. Excellent. Thanks for joining. Maruthi from Kandakur, India. Nice. Welcome to the stream. Thank you. Anonymous person from Orlando. Excited for Partitioned Queues, aren't we all?
Like that.
Yes, good. Jason makes cache relevant. I'm not sure I get that. Rob, do you understand? Maybe it's above my pay grade.
I'm not exactly sure.
Jason, if you want to describe a little bit more there. We are going to talk about, we will definitely talk about what happens in a rebalancing and the consumers going and coming. So don't worry. We're going to get to this question in a little bit. So, all right. Sorry, Rob. All right. So we got our consumers, we got our partitions.
Yeah. So, and you get this and then it's all running fine. But what we also want to be able to do as a retail group is be able to scale this up automatically. So for example, let's say, you're chugging along, you're now up to 10 partitions, 5 consumers, and Black Friday's coming. And you're the hottest thing in the market. What are you going to do? How are you going to scale this? Well, it's actually not a particularly difficult problem to solve. The industry's got, Kubernetes event-driven auto scaling out there in the marketplace that can take your microservice and automatically spin it up based on operational statistics. You can look at your partition queue and go, this is getting heavily loaded. I need to add more consumers to drain it faster. And it'll automatically spin up a new consumer. And in that case, this new consumer goes in, it binds to the partition queue, and the partition queue will automatically go, okay, well, I have 10 partitions, 5 consumers initially, and so they're mapped 2 to 1. But now I've got a new consumer, and so I've got 10 partitions, 6 consumers. So I'm going to go down to 4 consumers with 2 partitions each, and two consumers with 1 partition, and run that way. And the way that works is when the consumers, the number of consumers changes, whether you take down a consumer gracefully, whether it disappears because it crashed or network failure, or you add new consumers, and a lot of customers will actually do like 3-5 consumers at a time when they spin up with KEDA. So we actually hold down for a period of time. The default is 5 seconds, but you can configure that to be significantly larger. And what you want to do in that time frame is have the number of consumers stabilize, so that you're minimizing the amount of change that actually happens inside of the partition queue.
So as soon as you add or remove 1 consumer, this hold down timer kicks off, and it's kind of just waiting 5 seconds to make sure that it's not changing again.
Right.
And so like if you're going to add a bunch of new consumers or something, you'd want to add them kind of fairly quickly within that. Or is it 5 seconds from the last change? So if you add one every 1 second, then it's just 5, 5, 5.
It's 5 seconds from the first change, but as I say, it's configurable, right? So if you're going to bring up, 5 different microservices, it may, a few seconds you may actually want to put that at like 20 seconds or whatever. Right. It's really going to be up to the customer how they configure that. But if you're only bringing up 1 at a time, 5 seconds may be more than sufficient.
Okay.
So we hold down for that 5 seconds. And in this case, what happens is once that 5 seconds has occurred, we determine where we're going to take that partition from and where we're going to move it to. And so, in this case, we've got partition number 6 moved from the first consumer to the last consumer. And it will allow that first consumer for a second period of time. And the default is 3 seconds. It'll allow that first consumer 3 more seconds to totally drain the queue from the point where everything was changed. So anything that consumer still has to pull, it gets 3 seconds. Once that timer is exceeded or that consumer has totally drained that partition's contents prior to the switch, then the new consumer will start to get all the new events that come in since it made the switch, and that's how it occurs when you add a consumer. Same thing if you lose a consumer. In that case, if you do a graceful shutdown, you can actually still draw from it. If it's a not so grateful thing because the network went down or the consumer itself failed, then it's probably going to play out that timer. Now, if the timer plays out, what happens?
This is the 3 second by default timer, right?
That's right.
Okay, yeah,
that's right. 3 second default timer. When that plays out, you'll have it'll still go to the new consumer. The events that were consumed were to be consumed by the original will actually move to the new consumer.
Okay, so I have a question from a customer of mine. I was in Hong Kong last week, and they were wondering what happens if during a rebalance, a message is consumed by, say, consumer, the original consumer, but not ACT. Would the message get redelivered to the second guy because that kind of message is outstanding?
Yeah, it would.
Okay.
It would, because it wouldn't be considered successfully delivered at that time. So
Right.
there is a possibility of multiple
dupes.
Duplicates, right?
Yeah.
But we saw that as a better alternative to losing events, right? Which would be the other option here.
3 seconds seems quite aggressive. Like if your queue is filling up, you might want to tune that to, I don't know, like, I guess you want it to be like, you don't make it 5 minutes and then the queue's just kind of sitting there for 5 minutes waiting for kind of like the things to finish draining. Yeah, I guess it's kind of just like the 5 seconds. It's configurable based on the customer's use case and
that's right.
And is that per queue, that setting, or is that kind of a general setting for the whole broker or VPN?
That is on a per partition queue basis. So
per queue basis.
Yeah.
Okay.
You may have multiple partition queues set up, and they may have different policies around auto scaling, and so we want to be able to accommodate that based on what you're doing on a per application basis.
All right, I got a few comments here. Just take a pause. Srinivas asks when this feature is going to be available. It's coming soon, from what I know. I don't have an exact date. Rob, you may know that.
Yeah, well, we're currently tracking to the end of April, so that from a broker standpoint. So that's a preview release, 10.4.0, and that means it'll be in the June LTS production release as well, and in PubSub plus Cloud in July.
All right, yeah. So you'll first be able to get your hands on it at end of April, hopefully, and then if all goes well, we'll be able to deploy it into production, kind of LTS, long-term support release in June. So that's cool. And the APIs, as you said, they all need to get revved as well because they have this new key being added to them that you have to be able to set this key in the publisher, right?
Yeah, that's right.
Okay. Phil from London. Hey, Phil. How's it going?
Hey,
thanks for joining. Ari just touched down. Hello from Jakarta. All right. Late for you as well. Late in the evening. Thanks for joining. Jason, on the microservice side, same context reuse. This is around the caches. Make cache relevant on the microservice side. Yeah, I guess. Well, I mean, the microservices are now kind of more stateful. Well, because of the queue, right? So, um, yeah.
Yeah.
I don't know. I don't have I don't have a comment on that, but um, yeah. Thanks for pointing that out. Hello, Aditya. How's it going? Thanks for joining. One more here. What's the depth of the queue partition? Depth in terms of messages or megabytes? Yeah, I assume it's just like any Solace queue. You specify the queue depth in megabytes, which can be from 1 meg to like a couple terabytes if you want. And then there's the size of each partition. Is it shared evenly across the whole size of the queue, or can they each fill up the? Yeah.
No,
So if you have
they're all split evenly in terms of size.
okay, so if you have a 1 GB partition queue with 10 partitions, each partition is actually 100 megs, kind of under the covers.
That's right. That's right.
Okay. Coolio. Oh, perfect. Mark, this is one of our canned questions, actually. What if the publisher doesn't set a key? Rob, I'm sure you have an answer for that because you gave me this as a question. So thanks for asking, Mark. I don't have to do it.
No, that's a common question. So what actually happens with a partition queue is if a message come in and it doesn't carry a key, it just randomly randomly selects a key through the hash function. So
okay,
or not a key. It randomly selects a partition through the hash function.
So it would behave more like a typical non-exclusive queue, I guess, in that way, right? It's just kind of it's not round robining across the consumers, but it'd be kind of just randomly spraying fairly load balanced across the different partitions.
Yeah, average load balance across the partitions. Yeah.
Okay. So yeah, so I guess if you're using an older API that hasn't been upgraded yet, or you just didn't set the partition key, then that's the behavior that you're going to get. It's not going to map the same. It's not going to know where to put. Yeah, it needs that key to know which partition you want to always go to. So, yeah. Thanks for the question.
We are looking at other behaviors in future releases, like looking at producer number or doing a round robin or even allowing you to specify a partition is another option we're looking at there for ingress. So different options will come up in the future, but right now it'll randomize.
Okay. Hello, Bangalore. Welcome. Yes, I've let another evening.
Today.
Yeah, that's right. Yeah, evening viewers. So thank you for joining. Happy to have you here. Okay, I have some more questions, but I don't know if you got a few more clicks on this slide here before if we finish talking about it. I can't. I don't know.
Yeah. So there's how does this compare to Kafka is something I get asked a lot. So there's some fairly big differences here. In a way, it looks very similar. But as I said earlier, this is really, you spin up a partition queue like you create a consumer group inside Kafka, and so it's not based on one whole topic gets a set of partitions that goes across multiple consumer groups. Here, you create a partition queue, and what you feed into it is actually a standard Solace approach with Solace topics and Solace subscriptions. So it's not tied to a single topic. The partition queue can take in whatever subscriptions you'd like to pull into that partition queue.
So like common best practice for guaranteed messaging in Solace pub sub is, you have your queue for your persistent storage, but you'll have it subscribed to topics, wildcarded topics, very dynamic variable topics. And so your one queue is going to attract, tons of different topics. So I guess the same for the partition queue, right? You could have every message going into this queue could have a completely different topic. We give some flight data as an example, right? Could have flight number, airline coordinates, even as part of the topic, and they're all landing in this queue. Quick question: will different topics with the same key always go to the same partition? Like, do we look at the topic at all as part of the hashing problem?
The topic is purely used to pull the event into the partition queue. To make that decision which partition, it's solely up to the key.
Right.
Now, if that's something you wanted to do, if context wasn't just some number or some value in a key, and you wanted to have let's say you had one topic that had 90% of your load, and you wanted to balance it more across things, you could absolutely generate a key and add a pen to the front of it, that topic, because our key is it's at least 128, if not 256 byte string. So it allows you to concatenate a bunch of different variables into a single key if you want to do that at the publisher. So you can do it that way.
Okay. All right, cool. Let's see. Any other questions? Hold on a second here. Maruthi, tell us. What if the message got stuck and unable to consume the data? How can we investigate which offset is not consumed by which consumer? So offset is a very Kafka-esque term. Solace doesn't really use offsets and checkpointing for its recovery. We do have replay as well, but the way queuing and recovery works in Solace is that each message is acknowledged individually, which gives you a very fine-grained control as to what you've seen and what you haven't seen yet. And so as you process each individual message, you can act each one specifically. If the message gets stuck, Solace has a bunch of features around redelivery, around you can set time to live on your queue that can expire a message if it gets stuck. We have the concept of a dead message queue, or dead letter queue, you might call it, kind of an error handling queue that we can automatically move a message stuck at the front to that queue. That can be based on maximum redeliveries as well. So if it's like a malformed message, payload's incorrect, and your consumer keeps crashing, after 5 or 10 retries, you can have that message automatically flush to a DM queue. And we've actually, just a couple months ago, last year, we added the ability within the broker to actually copy messages from one queue to another. So if your message is stuck in your DM queue and you go and fix your consumer, you can actually go and administratively kind of move that message back into the original queue and carry on going. Previously, you had to like kind of use a client app to kind of copy it and paste it back into the queue. So yeah, lots of options around dealing with stuck messages, and redeliveries. I'm assuming partition queues are still Solace queues. They support all of these. I should probably have asked, right? They support TTL, they support max redeliveries, and all that kind of stuff, right, Rob?
Yeah. Exactly. Yeah, they support all that capability. In a way, a partition queue is just a special example of a non-exclusive queue.
Right. It is.
It's
a sticky non-exclusive queue, I guess. So
the other thing I've got to kind of admonish you for, Aaron, is you forgot my favorite way to do this.
What's that?
Distributed tracing. You can trace an event through the broker now and see exactly where it is, where it got stuck. You can, with partition queues, you can even see what partition did that
that's cool.
event go through, and feed that out to observability tool and understand exactly what happened to that event, and you can pull it from a replay log and send it to another destination if you wanted to.
In my defense, yeah, I will say that distributed trace is a pretty new feature. It just came out, and I haven't played with it that much, and it's not at the top of my mind. But yeah, you're absolutely right. We have the replay capability built into the broker, and yeah, distributed trace telemetry. You can track every single hop that a message will take throughout the broker. So lots and lots of ways to do troubleshooting there. So cool. I have a question. So what do the consumers know about the partition? Like, do they know which partition they're connecting to, or how many they're connecting to, or anything like that?
No, at this point, the consumer is only aware of the key. So we pass the key through to the consumer so they can reuse that information.
Well, it's part of the message, right? I mean, it's just like getting the yeah.
So we don't take it out or do anything beyond process it at the hash function, but we are not adding any information to the consumer about partition it was connected to. All that information is stored inside the partition queue. And quite often a question I get after I get asked that one is well, if my consumer goes away and it comes back in that 5 seconds, how do you know that it's that consumer that's come back? And what we've done is we've maintained a lot of the state information about that consumer and the flow that we had with that consumer for those 5 seconds. And so if it comes back, if you have a consumer disappear and it comes back within the 5 second timer, we just treat it as things are back to normal and keep on running in that case.
Okay.
But no, the consumer isn't aware.
Besides distributed trace, is there logging on the broker, like the event log or something that kind of tells you which consumer bound to the partition? Or I guess it doesn't really matter is that much. The broker just kind of, just handles it for you. Okay.
The broker just handles it all for you. Yeah.
So we got another question here from Maruthi. How can we achieve order of message delivery? Well, Solace queues are FIFO queues, first in, first out. And even if you had multiple queues subscribed to the same set of topics, order guarantee is order of messages is guaranteed in Solace for all consumers listening to the same set of topic streams. So, right. So obviously, like if I was just looking at this picture here, you had a consumer that was consuming from multiple partitions. There's some amount of parallelism there, right? That, they're draining from two different partitions. Is it the same flow? I mean, so like as in Solace talk, when you bind to a queue, you get a flow, right?
Right.
And do you get one flow per partition, or is it just one flow to the partition queue and the broker knows that it's sending multiple partitions to that one flow? Right.
So that's a great question. So when you bind to a partition queue, you get an inactive flow. And then whenever you have a partition assigned to you, that will become an active flow. But you'll only get one flow indicator, and it's just to the partition queue itself.
Right.
When you are using a partition queue, the in-order delivery is maintained within a key. So anything that comes within the key or gets dumped into a partition, once it's put into that partition, everything within that partition is delivered in order.
Right.
So you're by using a partition queue, you're recognizing what you care about is the order of delivery within that key's context, because as you said here, Aaron, we're doing a bunch of parallelism in order to create this load balancing. But what's key around a partition queue is that you maintain that context awareness and the in order for that context awareness. And that context can, in this case, because it's not just a single topic, it can span multiple topics.
Right. Okay. So it's the order of guarantee has moved to the partition now.
Right.
Because we are doing this round robin, right? Just like a non-exclusive queue, there's parallel, things. So if you could get possibly out of order, if one consumer crashes and it has to redeliver those messages to somebody else, they can go behind the original message. So, but with partition queues, then it's guaranteed on each partition. Right. JT here is asking if the partitions are sized equally. I think yes. That's what you said, Rob. Right?
That's right.
In this case, it would be divide by 10. So if the partition queue is a gig, each is 100 megs. Right?
Right.
Okay. Ari says, yeah, distributed trace. Yes, of course. Distributed trace has to work with all of our guaranteed messaging features. So very cool.
It is.
To see how the I guess you'd have a pretty good indication as to if the hash is working nicely. Yeah, in terms of the key recommendations, I assume you want a fairly large number of keys, right? To make sure that you get a nice, because if you only had 5 keys and 10 partitions, obviously you're going to have a bunch of empty partitions because like you can only have 5 keys, right? So
that's right. Like when you're actually looking at a key, what you're trying to get to is something that is unique. It's numerous, so you've got a large number. It fits the use case of what you're trying to manage, and you can contain it within a 255 byte string, which is a huge value. And I've got a huge number of examples here, and you can even put, an IP address with an employee number or whatever together to create, a whole new context here. But really, for partition queues, you're looking at the use case where you're talking a large number of keys. Otherwise, you could do the same kind of capability if you're by putting the key into your topic and feeding that into an exclusive queue, right? And having multiple different exclusive queues mapped to, a fixed set of small number of keys, and that would work, equally well here. But when you're talking, the number of orders or the number of flights or transaction numbers, these are really big numbers, and it actually works really well to have a large number of keys, because that means you get things very randomly distributed, and you're going to have a very efficient use of your partition queue.
Right. Yeah. So you mentioned something that I did want to touch on. So Solace has had, because we have multi-level topics, the ability to actually build a partition as part of the topic string. I actually wrote a blog on this. If you Google Solace consumer groups, you'll find it. And so this is how the approach that a lot of our customers who need this kind of sharding of their messages into multiple kind of parallel streams with order being guaranteed across a particular key would do that. So one level of the topic would be, like the modulo of the order number, for example, you have there. And each of these queues, you'd have multiple parallel exclusive queues, and they would each be subscribed to some part of that, modulo for that particular key. So, so that's worked really well. Obviously, a little bit more complicated. You have a lot more manual kind of configuration. You kind of, as the administrator, have to decide, the queues and the subscriptions, and the publishers need to include a partition key in the topic. So, quite a bit more involved, I guess, than doing it with this new fancy way, right? So,
right, and certainly auto scaling would make that even more complicated. Right?
Yeah. I was just going to ask. So, in terms of the differences between the two kind of those styles of horizontally scaling, I guess functionally they're kind of the same, but just partition queues takes care of a ton of automation, the rebalancing, and all that kind of stuff for you. So you don't have to build that logic into your actual applications, right? So
that's right.
Okay. All right. Let's see. What do we got here? Another question. LinkedIn, an anonymous user. From consumer code, I am only accessing messages from the queue. Any code needed to write a consumer end to access partitions as well? Any GitHub link to understand? So no, you don't. The consumers don't know about the partitions. They are just connecting to the queue. They're binding to the queue, and the broker will decide which partition or partitions they will be assigned. And as you said, they'll get an active flow when that happens, and they'll start to get. In terms of GitHub links, nothing yet because it's still not released. This is an upcoming feature. We will have documentation, obviously, and hopefully maybe a sample or two if it makes sense. But if it's I guess we probably will want some samples because it's a new API, right? And they're going to have a key.
That's right.
Yes. So stay tuned on that. I'm sure we will have some.
We'll want some samples that show you your what procedure you need to call or how to set a key. Yeah.
All right. We got a question from Mark here. You mentioned that all queues are the same, all partitions are the same size. What if one consumer is slow and the only one of these partitions fill up? Does a queue reject messages that would end up on other partitions? That's a pretty good question, actually. So you have a 1 gigabyte queue. Only one of your partitions is maxed out. It's 100 megs. So that means most of your queue is empty. What happens if does the publisher get pushback? Do you get NACs, or how does that work?
Yeah, so at that point, if a message was to go into that partition and the partition is full, then it would get pushback for that single partition. Yes.
Okay. All right. Okay. So there you go. In terms of like, counting quota, or not quota, but like, does one partition queue count as one queue, or is it the number of partitions counts the number of queues? Like if you have a small broker and we're only saying you only get 100 queues, I'm assuming you can't make 110 partition queues, right? Because that's a lot more power. So
Right.
Are we counting each partition as against the number of endpoints on the broker?
Yeah, in fact, it's a little bit more than that. It's whatever the number of partitions in the partition queue plus the partition queue itself. So
plus one. Okay, so n plus one. Okay.
For each partition queue you have. So if you've got, a partition queue like we saw before with 10, then this would be 11 counting against your endpoint count.
Right. Okay. Which makes sense, because that's how you'd have to build it anyway if you want to do this yourself, right? So
that's right.
So I'm kind of aware of the time. I want to make sure that we get to it. I know you have a demo, and we've got a lot of questions. So let's whoa, JT, what does that mean? We lose the messages? No, you don't lose messages. So in Solace, if a queue is full, by default, the publisher will get what's called a NAC, a negative acknowledgement, to tell that the broker is saying that the queue has filled up to whatever size you've configured that queue, and it can't accept any more messages. So it's certainly not losing in the sense that it's been accepted for delivery, and the guarantee is there and then just somehow disappears. No, it's basically the broker says slow down, wait for the queue to drain a little bit. So I want to get my terminology right, that we're not losing messages. The broker just does not accept messages if it can't enqueue them. So
right. So the publisher is aware it can republish at a later time. Yeah.
That's right. Okay, so I'm going to share your other screen here.
Mm-hmm.
It's just a big white. Okay. Oh, it's the broker. Oh, it's publisher plus admin. All right. So is this I guess this is a EA version. This is not, since it's not public yet, this is your Skunkworks internal build.
Yeah, it's not even EA. It's a dev version.
It's a dev build. Okay, awesome.
That they felt they could actually release to a product manager. So that's a vote of confidence. That's not quite EA, but it's up. Cool. It's up there.
Okay. All right.
So what I'll show you is actually creating a partition queue on this. So
sure. Okay.
Let's go into the broker, and then we go to queues.
Create a queue.
And we will create a queue. And I'm going to call this one partitioned. And what you see is the standard standard queue creation
dialog.
But dialog, But what it's got is now it has partition count in there.
That's new, but it's grayed out.
That's the new part. It's grayed out. But if you click on non-exclusive,
all right,
it comes out.
It is a special non-exclusive. Cool. All right.
It's a special version of a non-exclusive queue. Exactly. And if I click on the advanced settings, that's when you get to see some more of the detail here. So that rebalance delay timer that I told you about, where you can change it. You can go in here and set it to whatever value you want to change it to. Similar, that maximum handoff time, that period of time that the previous consumer has to drain the queue prior to the switchover, that's settable here as well. So it's very simple to set up.
If the partition count is 0, is that just a regular non-exclusive queue, like a normal one, or
yeah,
1?
That's right. It'll create a non-exclusive queue.
Okay.
So for example, I'm going to set the count to 12.
Okay.
Okay, and we'll apply and tell it to make the changes. And part of what Dev is actually currently working on is something that looks a lot prettier than this, but you can see there are 12 kind of sub-exclusive queues here, and
each partition.
partitioned itself. Now, this is a special queue, and there is no actual distribution or holding mechanism in this one. It's just held to do the hashing and then immediately put into the other queues. There's no depth to that one. So,
but it exists by name, right? I mean, like you can publish to that queue called partitioned. You bind to that queue called partitioned. It just doesn't store anything.
That's
all kind of wired up to these other ones. Okay, cool.
Right. And the other thing that's important about it, and we can go into it here, is being able to set up subscriptions on it.
Yeah.
So for it to work, we'll post to this Solace topic. But as you can see, it's unlike Kafka and other technologies. You can create as many subscriptions as you want in it, just like you can with a typical Solace queue. So
you're not using wildcards? This is just a single topic on this queue?
If you want, I can use a wildcard.
if I want. Well, I don't know what you're publishing into this thing. So.
Well, I mean, I can take that out, and we can do test star. That would still work.
Sure.
Pick it out.
I always like,
You like the wildcards?
Nice wildcards. Yeah, exactly.
They're pretty cool. All right, and so what you actually have at this point is a partition queue that can actually take in and remove data.
So quick question, Rob. It's showing 5,000 is the quota megabytes, but that's not true. Like that should actually be, each should be 500. Yeah, okay. So it's a dev build, everybody. This is not how it's going to look in the real version.
Yeah, it's going to show up with the partition queue itself being 5,000, so that's accurate. But the information you see above, that's what we need to clean up. Okay, and that includes the quota size. So what I have for you to showcase how it all works is a little capability that our VP of engineering, Ed Funakater, has worked on. He loves Portal, and so he's created a number of these little examples of how you can use Solace technology to convey messages from a consumer, which is what you see, or a producer, which is what you see up here. It's actually generating the message in this module. It'll roll down the ramp, and then once it goes through this green ring, and green means it's actually connected to that partition queue I set up previously already.
Okay.
It's going into the broker, and then we've got 4 different consumers that we've spun up underneath here, and you can see how they would be sorted out into each consumer, each flow. Okay. So just as a reminder to everybody, what we've got is a producer, 12 partitions, and 4 consumers.
Right.
And so those 4 consumers are going to be mapped each to 3 different partitions. And
definitely 3. They each get 3. It's not like some could have 4 and some could have 2, right? Okay.
No, it's really about balancing. That rebalance algorithm is really about balancing the number of partitions to number of queues.
Okay. I guess they'd always be plus or minus 1 of they ought to be the same, right? So okay.
That's right. There'd be one plus or minus 1 of each other. Yeah. All right, so let's, I'll just send down 1 just so you can see how this works. It went through and we got a blue ball. And blue balls, the ball color is actually important here, because what you can see, if I go into the config here, is that the partition key, we're using the color to define that. And you can see we're publishing on test 1 here. So it allows you to, it will actually publish all this on test 1. So it'll be pulled into that partition queue that was subscribed to test/star. Okay. And we'll have 8 different colors of balls going through here.
So that's why, you had your queue subscribed to test 1. So every ball is being published, quote unquote, on test 1. and the partition key is the color. Okay, cool. So yeah, so all the colors, the same colors should go to the same partitions, right?
That's exactly how this play out, right?
Yeah.
So let's get a stream going. So we start sending some balls out, all these different colors, and we'll see over time where they all land, right? So they're all flowing in, and let's see,
now,
just randomly, you're going to notice sometimes different partitions don't have the exact same number of balls as the other ones, and that's just the way hashing works.
We only have 8 keys and 12 partitions, so yeah, you're definitely going to have some partitions that aren't getting anything. So
right, and this is an example of why you want like a large number of keys, and I can actually go in and emulate that with dual colors and make balls that are 2 different colors, but we find that that's actually hard to do over streaming. It's hard to tell. So I've paused it here. I'm going to start it up, but what I'm going to do is I'm going to fail one of these consumers, right?
Okay.
Let's see what happens when we fail a consumer. And I'm going to fail this one just because it's got so many different keys attached to it, and we'll see how it sorts out. But we'll get it going, and then I'm going to turn it off. And
so that is essentially killing the consumer that's attached to those partitions.
Right, and you notice if I turn it back on, within the 5 seconds, all those balls that were queued up just come pouring out.
Yeah.
And everything continues normally. Right?
Okay. Yep.
But let's actually do it for.
So a small blip. Is that 5 seconds hold down you were talking about? So if it was 30 seconds, it would be this thing has a 30-second grace period to reconnect?
That's right.
Right. Okay. Okay.
Well, no, it's actually not tied to that time. It's when I connected back, right? Because I came back and immediately came back. Like if I do this and this, they just okay.
Look,
I'm wrong.
Mm-hmm.
Developers are going to tell me, "Oh, you said the wrong thing." I know they are held to that timer then. Yeah.
Okay.
So there we go.
But if you kill it for too long,
if I kill it for too long, it will complete that hold down time, and we start to see those balls pour out in different places. So you can now see black and blue is going to this partition number. We'll call it number 2 over here, and the yellows have gone to number 4, right?
Right. The lime colored ones.
Right.
Okay.
So and at this point, we've got 12 partitions still, but each of these 3 consumers would now have 4 partitions after it.
Right.
Right. But you don't know which ones which partitions the keys were mapped to. They could all, the black and blue might be on the same same partition. In fact, they would be because one of those partitions moved from here to each one of these partitions. So this one didn't have an active change there because it had black and blue and yellow weren't part of that. But the partition this one was using for yellow moved over to this one, and this one clearly the same partition was being used for black and blue, and that's what fed into that one.
Is there any indication to consumers, like the consumers that are still alive, that things are changing, like a rebalance has occurred, or do they just need to look at the keys and say, oh, I'm starting to see new keys that I've never seen before. I know that things are different now.
Yeah, that's how you would look is based on the key that you're receiving.
Okay. Here's just a quick question here from Srinivas. How to determine the partition count? Well, it's kind of a sizing and kind of a bit of experimenting kind of operation. I would guess as a very rough cut, you build your backend consumer app, your microservice. You can figure out how many messages per second it can process, and you look at your load. You kind of look at your peak load, I guess, and you want to kind of choose that if you're getting 10,000 messages a second into your queue, and each consumer can possibly do 1,000, then it sounds like you're probably going to need 10 partitions in order to kind of keep up with that load and have it partitioned. Well, more or less, right? I mean, I guess it's probably somewhat experimental, right? Because you could have some partitions that are hotter than others.
Yeah. I mean, I would guide you to, this kind of a classic Kafka problem that we're seeing here too. And what the general guidance is, how many consumers do you think you'll ever need attached to that partition queue? Because really, when you want to change the number of partitions, it's a much bigger event than changing the number of consumers, right? It's a big rebalance, and what you actually have to do is pause ingress, allow your information to drain, and then increase the number of partitions, and then allow ingress back in. It's a bit of a stop everything for a bit of time. In Kafka in particular, that's what you would do. Here we have a bit more flexibility. You can still do the exact same thing. You can pause it and resize the partition queue itself. The other way you can do it with Solace is, because we aren't one and only one set of partitions for a topic, you could actually create a new larger partition queue, have messages consumed by both queues, and move your consumers over to the new partition queue when you want to rebalance it. Or the other kind of nifty benefit is, because we're able to consume multiple topics, you can actually break down the topic space of one partition queue and say, okay, I'm going to move like half the topic, the topics onto a brand new partition queue, and approach it that way. So there's a number of options we have here, and we can size up and down the number of partitions through these mechanisms too, and that's something you can't do with Kafka. But it's a good question. I would honestly say, figure out partition queue based on, when this application you're looking at is wildly successful, what's the maximum number of consumers I'll have running on it, and hopefully you never have to have that running at have to do the rebalance. And the way this works, because it'll just map to however many consumers you have, you're not losing any queue space or anything like that, having multiple partitions. You're just you're going to have that endpoint count size to
that's the only thing, right? Yeah,
so that's the only thing.
Yeah,
but if you think you might get there, it's probably best to have your broker sized in case that's going to happen anyway.
Yeah. So yeah, as you said, I guess, changing the number of partitions is a bit of a bigger operation, but it's certainly, if you had like a kind of a maintenance window or you could have some downtime, it's not that hard to do. Just drain out your queue and change the size and carry on. I like the idea of kind of sharding your topic space. That's what we used to do for Sol cache or PubSub Plus cache. Now, as one cluster got overloaded, you would kind of split the topic space up using wildcards, using A star, B star, C star, go to that cache, and D star, E star, F star went to that cache. So yeah, quite a few options. I assume we'll have maybe some documentation and some guidance around how to use this feature and kind of sizing and stuff like that when we do get it released. JT, that's an awesome visualization. I agree. Thanks again. Shout out to Ed Fonacutter for building this awesome JavaScript demo. I think, Rob, you use this for some other demos as well, right? Like it's showing non-exclusive, exclusive, and partitioned, and how these different.
He's done a couple other ones. I've just borrowed it for this because it just works so well.
Yeah,
the last thing,
not ours, but yeah. Thanks, Ed. Thanks for letting us use it.
Yeah. The last part I want to show is if you actually reconnect, right? And what you'll notice upon reconnection. I should have done this first, but
yeah,
it won't matter.
They're getting pretty full here.
Right, they are getting full. What you'll notice is it's connecting now as a new consumer, right? So it's not necessarily getting the exact same keys that it got before.
That it was before.
it's a brand new consumer. So you can see 5-second hold down timer, and then it's been rebalanced into 3 partitions.
Yep. Cool.
Okay.
Yep. I like this. I like this this visualization as well. All right. So let's see. What's we're running out of time. Jason, this is gonna be the last question here. Can the partition queue scale by the number of consumers that connect? That will allow the elastic container to drive the scaling by the normal traffic load responsiveness. So the partition queue scale, like the number of partitions, I guess, yeah, that's what we just kind of answered. That no, that's a bit of a it's a administrative kind of somewhat offline, somewhat heavy-handed kind of change to make. So you would size the number of partitions based on what you expect to probably be your peak load, more or less, and then your number of consumers would be the things that scale up and scale down quite dynamically based on the actual load.
Right, and in a way, it's the partitions being able to have multiple partitions feed into the same consumer actually provides this kind of elasticity, but it's in kind of units of partition. So so there is that elasticity, but it's not like we can scale up a partition queue that it's consuming more, quota or whatever based on number of consumers. That wouldn't that would run into problems if the broker was running out of resources or things like that. So here you predefine all of that, and the number of partitions per consumer allows you to have that kind of elasticity.
Right. Yeah. All right. Okay. Awesome. And just one last one. Is it available now? Not quite yet. It's coming in end of April if all things go well, if QA are happy with it and everything moves forward. So that'll be the first release. And then in June will be Solace's what we call LTS, long-term support release, 10.4.1, I think you said, Rob.
Yep.
So, but yeah, you'll first be able to get your hands on it, the Solace broker, the Docker container, whatever, at the end of April. So, yeah, and you'll need to upgrade your APIs and your Oh, in the cloud, yeah.
Not long after that, right?
July-ish sometime. So, cool. Yeah, you'll have to upgrade your APIs because the partition key needs to be set by the publisher when you're sticking it in there. So, and good.
Excellent.
We have a lot of customers that are very excited about this feature. So yeah, glad to hear it. Well, thanks for joining everybody, and thanks Rob for joining my office hours. I know you're a busy man. It's the middle of the day there. It is pretty late at night for me. I'm going to go to bed pretty much after this. But thanks for all the questions out there. Yeah, it's gonna be good. Check out the Solace community. We'll definitely have a post up there when it goes live. Mark reminded me that yes, we'll definitely have some samples for this. Obviously, there'll be documentation. So lots of bits and pieces around this new and exciting feature. Rob, thanks again. Want to say any last words here?
Thanks, Aaron. This was a lot of fun. Glad to see all the excitement about partition queues.
Yeah,
we're looking forward to getting it out to you.
Yep, awesome. All right, everybody. Thanks very much. I'll see you next month. I don't know what my topic's going to be yet, but yeah, be sure to tune in. I'll do it towards the end of March, and look forward to seeing you then. Thanks, Rob. See you guys.
Thank you.
All right. Thank you.